Hello and welcome back to Business Statistics. Today we're looking at continuous probability in Chapter 7. Chapter 7 looks at the smooth bell curve that shows a population with a normal distribution. We saw in previous chapters that a normal curve can be graphed differently depending on the mean mu and the standard deviation sigma. A normal distribution means that it's symmetric around the mean. So the area under the curve is going to be the same left of 0 as it is to the right of 0. 95% lies within 2 standard deviations of that mean. We also looked at the Z formula on the last chapter, where Z is equal to the observed value x minus the mean of mu divided by the standard deviation of sigma. So we also took a quick look at the Z table where we can look at values for Z. And we're going to do some exercises today to go ahead and be able to help with the chapter exercises that you're going to get to do for Chapter 7. So let's take a look. So the continuous probability here, the exercises we're looking at, is when we have a certain value for Z. And we're going to take a look on the Z table to try to figure out what those values are going to be. So for continuous probability, we use the formula Z equals x minus mu divided by sigma. In the example when Z is under the curve with a value of 0, between 0 and 1.5, the way we would look that up on the Z table is basically we just go to the Z table, look up the column for Z, and try to find that value under the curve. So in this case, it's between 0 and 1.5. So the way we're going to look it up is just go down the table, look up at 1.5, and that value is 0.4332. So again, not rocket science. We just find the value between 0 and 1.5, which is equals 0.4332. Now, what if we have a negative value under the curve? So in this instance, we have minus 2.1 and 0. The way we would look at that value is because, again, under the curve, the value of C is symmetrical on both sides of the curve. A minus 2.1 would also be equals to a positive 2.1 under the curve. So again, the way we would look at that value is we go to the C table, look down this column, and look at the value for 2.1, which is 0.4821 right here. In that case, the value of the curve between 0 and 2.1, which is the same as the value between 0 and positive 2.1, is going to be 0.4821. Now, what about if we had an area between 0.6 and 1.8? So our area is not starting at 0, it's starting at 0.6. How do we look up that difference? So the way to do that is on the Z table, we're going to go ahead and look at the value of 4.6 and then look at the value for 1.8 and then subtract from one another. So looking at the Z table again, we look at the value under the curve. As you can see, that value is going to start somewhere around here as opposed to at 0. So for 0.6, that value is 0.2257. We're going to note that down and then go down to 1.8, and that value is 0.4641. We're going to note that down as well. So we go back to Excel. We note down the value of 0.2257 for when the area starts at point Z, at 0.6. And then for 1.8, that value under the table is 0.4641. When we subtract one from the other, we end up getting 0.2384. And that's going to be our value for z when the value under the curve is going to be between 0.6 and 1.8. Finally, we have an example of when the z value is on both sides of the table. So the area is going to fall on the negative side of minus 0.3 and through the positive side of 2.25. So similarly, as we looked at before, the z-table value for z equals minus 0.3, because it's symmetrical, is going to be the same as positive 0.3. We will also look up the value of 2.25 under the table and see what we come up with. So again, 0.3, we'd go down easy enough, it's 0.1179. But for 0.25, what ends up happening is we have to look down at this value on this column, so 2.5, and then find out what that value is and add it on the table. So for 0.3 is 0.1179. For 2.25, the way we're going to look that up is a little bit differently. So we go down the z column, we look at 2.2, but what we want to do is go down the rows up until we get at 0.05 up here. So in that case, 2.25 is going to fall under this value right here, which is 0.4878. We make a note of that. And then similarly, when you subtract a negative number, you actually end up adding it. That's what we're going to do here. So instead of subtracting from one another, we're going to add them, and we come up with a value of 0.6057. Note that in order to do this exercise, we are not adding or subtracting the values themselves and then looking up the value on the z-table, but rather we're taking the value of z for 0.3, the value of z for 2.25, and then adding those values together. So make sure that you keep that in mind when you're doing your exercises. Now the next thing we're going to be covering in this chapter is the conversion of raw scores. Now, in order to do this conversion, it's not too complicated. We did view this briefly in the last chapter. We multiply the z value by the standard deviation and add the mean. So in this case, for the conversion of raw scores, what we're going to do is we're going to take x equals mu plus z times the standard deviation sigma. So in an example where we have a mean of 300, a standard deviation of 60, and a z value of 0.385, our raw score would be easy to calculate just by taking sigma plus z times, mu plus z times the standard deviation, which is sigma. In this case, then, we would take the mean 300, we would add it to the standard deviation of 60 times the z value of 0.385, which was given in the question. That would equals 300 plus 23, so the final answer for your raw score in this instance would be 323. Now, Chapter 7 then introduces us to the central limit theorem. There is a good YouTube that you might want to check out called Excel 2013 Statistical Analysis, number 47, Central Limit Theorem by Excel's Fun. The central limit theorem ends up being one of the most important concepts in statistics, so it is something that you want to become acquainted with. We're introduced to it briefly in this chapter, but we'll get into more detail in later chapters. What we do want to look at before we finish this chapter review is the standard error of mean. Now the standard error of mean, the formula for that is going to be your mean mu is equal to your sigma for standard deviation divided by the square root of n. And what you will need to consider here is a range where mu lies usually between the values of 0.90, 0.95, or 0.99. Again, there's a good YouTube on standard of error in Excel by Vivo that you might want to check out before you go on and do more exercises on the standard error of mean. Hope this was useful to you, and we'll meet back again for a review of Chapter 8. Thank you and have a good one.